Okay, so now on to the last example of writing the equation of a polynomial when we're given the zeros. So again, this is very similar, well, actually very similar. It's exactly basically the same thing, same operation that we've done for real zeros as well as for real irrational zeros. So real rational and real irrational, we did this exact same technique. So we're going to do the same thing. The only difference here, you can see that we have some imaginary numbers in each one of these problems. And the important thing that we want you to take away from this is, again, remember the complex conjugate needs to exist. So even though I have I here, remember that positive I must exist. And again, for each one of these, you can set these all, you can set each zero equal to x, right? So like x equals I, x equals negative I, x equals 1/2, x equals negative 1/2, and x equals 0. Now, usually for the next one, I'm going to kind of skip this step. But again, remember to set them to determine the zeros. You just set them equal to 0 to solve. So x minus I equals 0. You add the I in this case. X plus I equals 0. Here you're subtracting 1/2, right? And therefore, you're going to get x minus 1/2 equals 0. This one, you'd add a 1/2 equals 0, so x plus 1/2 equals 0. And here you could just write x minus 0 if you wanted to. Sometimes I like to do that. So this is the list of basically all the factors. So then to write the equation, you basically are just writing the linear factorization of all the factors. So x minus I times x plus I. Now, the important thing here is actually, I meant to talk about this. We don't want to do minus 2i plus 2i. We don't want to just subtract those over. The better operation, what to do, is instead of subtracting, and I kind of just started thinking ahead, instead of subtracting 1/2, which you could have done, it's going to be better to not to multiply by 2, so therefore you get 2x equals negative 1, and then to add a 1 to both sides. And so what that's going to do is that's going to give you 2x plus 1 equals 0 and 2x minus 1 equals 0. So that's going to be the operation we're going to want to do, because if you were to multiply these, then you're going to have fractional coefficients, and we don't want to be dealing with a polynomial with fractional coefficients. So either way, these are my two zeros, so I'm going to write them as that. Again, it's really the same. You're not changing the value of the factors, but you are going to change, because then you are going to write your polynomial, though, with rational with integer coefficients. And then let's just write it as x minus 0. Why not? Okay, so now here's our linear factorization. The nice thing that we notice here is, whenever we have the complex number and its conjugate, we're going to have difference of two squares. So again, we don't need to multiply everything out to cancel out the middle terms, or for the middle terms to go to 0. We can just multiply the first two terms together, which would be x squared. Multiply the second two terms together, which would be I times I, which is I squared, and then a negative times positive, so it's a negative I squared. And remember, I squared is negative 1, so it's minus a I negative 1, which would be a positive 1. In this case, again, we're going to multiply 2x times 2x, which is going to be not 2. It's going to be 4x squared. And negative 1 times negative 1 is going to be a minus 1. And then we have x times 0. Now, the only reason why I wrote this, which would just be x, okay? Now, the only reason why I wrote that out there, because I was just showing that these all have linear factorization, but x minus 0 is just x. Now, again, in this case, I'm going to multiply these. A couple different ways you can do this. In this case, we'll probably just use FOIL. I don't really see an advantage of using the box method. So again, remember, just FOIL is multiplying every term by each term. All right, so let's see what this x squared times 4x squared is going to be a 4x to the 4th. X squared times negative 1 is a negative x squared. Oops. Okay, now again, I'm not going to be multiplying with this x here. I'm just going to multiply these two binomials. And then now I'm going to use the vertical method. So I'm going to do, I'll just do the horizontal method actually. 1 times 4x squared is going to be a positive 4x squared. And 1 times negative 1 is going to be a negative 1. But remember, this is all still multiplied by x. Okay, now I'm going to apply distributive property with this x. So I multiply this times every single term. And now I have my final equation as 4x to the 5th minus x cubed plus 4x cubed minus x. And again, so if we have, we go back, again, referring to that fundamental theorem of algebra, we look at this, say we have a power of 5. That means we're going to have 5 zeros, right? And now we have real and irrational, and you can see that 1, 2, 3, 4, 5. So we're all good. Now I am kind of creeping into my space here, so let's do some different colors here. Let's do it pink for this one. All right, now for this one, I'm going to skip a step, but do notice that my complex conjugate here, it does exist. And then also I have this 3 with a multiplicity of 2. So when I write these as my factors, remember that multiplicity is basically going to be the power of your factor. So if these are my zeros, that means my factors are going to be, let's write this. I guess I can kind of write them in down here. So I can write this as a linear factorization, setting these equal to x and adding them in there. It would be x plus I square root of 2. Here, I'll do this one real quick. X equals negative I times square root of 2. To set this equal to 0, you're just going to add I square root of 2. Right? So we'd have x plus I square root of 2 equals 0. And you could do that for this one as well as for x equals 3. So then let's do the negative one. So that's going to be x minus I square root of 2. And then again, remember 3 is the 0, so that would be x minus 3, but it has a multiplicity of 2, so it's a repeated 0. Now, I can multiply these by difference of 2 squares. So some people might be a little confused, like, well, what do you do with I square root of 2? So let's multiply that out in different. So let's do I square root of 2 times negative I square root of 2. Well, this becomes a negative I squared times the square root of 4, right? 2 times 2. Well, I squared is 1 times negative 1. I think I talked about this, but I didn't actually go through it. Times 2. So that becomes a positive 2. All right, so therefore I have x squared, and that's going to be plus 2, right? Because I figured that out to be plus 2. And then this is a perfect square trinomial, which again, you could multiply this as x minus 3 times x minus 3. Hopefully, if you're a little bit familiar with expanding perfect square trinomials, you'll realize that you're going to get this, okay? Again, I'm just multiplying x minus 3 times x minus 3 using distributive property. But this is a familiar product, so that's why I'm using that method. So now we could use this using distributive property. In this case, I'm just going to use the box method just because I kind of like that method. So what I'm going to do here, as I'll do a different color, is I'm just going to create rows for each number of expressions I have, or terms I have in each expression. So I don't know why I did 3. Let's fix that. I have 2, and then I have 3. All right, so one binomial is x squared plus 2. The other one is x squared minus 6x plus 9. So again, remember the product is going to give you the area of this rectangle. So if I find all the areas of each rectangle, I can just combine them to get the total area. So x squared times x squared is x to the 4th. X squared times negative 6x is negative 6x cubed. X squared times 9 is going to be a positive 9x squared. You don't really need to write the positive, but this becomes a 2x squared. This is a negative 12x, and this becomes a positive 18. And what I like about this is, let's see, these are like terms. So I can just go ahead and combine them to write my final equation. Y equals x to the 4th, let's see, minus 6x cubed. 2x squared plus 9x squared is 11x squared minus 12x plus 18. All right, on to the last one. Now, the last one has the very, very lovely difference x plus 3i. So again, that means x minus 3i is a 0. And again, let's just practice doing one of these. So if that is my 0, that means I can set it equal to x. And that means I can set it equal to 0 to get my factor. So that means one of my factors is x minus 1 plus 3i. Okay? And then again, so if the other one was plus 3i, that means the other factor is going to be minus 3i. So my linear factorization is x minus 1, plus 3i times x minus 1 minus 3i, and then x plus 2. So in this case, so now what we're going to do is, I did work on this. You can multiply this by trinomial times trinomial and go ahead by when you're looking at the trinomial times trinomial method, you could use this box method and that works. But what we're going to do in this case is just going to use a shortcut. And what we're going to do is use the difference of two squares. And this is something I did for the irrational zeros product. And basically what you're doing is you're noticing that the x minus 1s are the same and the 3i's are the same. The only difference is you have an addition and you have a subtraction. So when since I recognize this as a difference of two squares, it's just like this. I just need to multiply the first two terms and the last two terms. And what's nice about this, when I do it, I get y equals, well, x minus 1 times x minus 1 is going to be x minus 1 squared. And then 3i times negative 3i, well, I times I is I squared, which is negative 1. 3 times negative 3 is a negative 9. So therefore, you have a negative 9 times a negative 1, so that's a positive 9. But don't forget, this is all still multiplied by x plus 2. All right. Now, I can multiply this out because, again, it's a perfect square trinomial. So x minus 1 times x minus 1 is going to be x squared minus 2x plus 1 plus 9 times x plus 2. And therefore, I get x squared minus 2x plus 10 times x plus 2. All right. And now we just need to multiply these out. So you could use distributive property. You could use the box method. I'm going to use distributive property. I'm going to use kind of the vertical addition method. So what that means, I'm going to multiply the first term times both of these, and then I'm going to write that out. And then for each term, I'm going to write below it. So I'm basically going to be adding the terms. So x squared times x is x cubed. X squared times 2 is going to be a 2x squared. Okay? And then now I'm going to take the negative 2x. Make sure you keep that negative with it. So now I'm going to do negative 2x times x is a negative 2x squared. Negative 2x times 2 is going to be a negative 4x. And then I'm going to take my last term and multiply that. So 10 times x is 10x, positive 10x, right? Positive 10x. And then 10 times 2 is 20. And then basically now I'm just going to write my final answer. I'm just going to kind of like vertically add these up. So I have x cubed, 2x squared minus 2x squared is going to be a 0x squared. Negative 4x plus 10x is going to be a positive 6x. And then plus 2. And obviously that is going to be equal to y. So there we go, ladies and gentlemen. That is basically your way to write the equation of the polynomial when given the zeros, if they are complex or with multiplicity. And just remember to use when the complex conjugate is going to exist. Thanks.